Good morning, everyone, and thank you very much for joining us for today's webinar, Usage of AI and IR Imaging in Energy-Efficient Retrofits. My name is Felix, and I'm the webinar coordinator at the Continuing Education Department here at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. To maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. We highly encourage engagement through our Q&A window. Feel free to submit any questions you may have for our speakers. All these will be addressed in the designated Q&A period at the end of the presentation. Kindly note, the chat function will be deactivated following this introduction. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for those hours to be accredited to your transcript. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. But now, I'm excited to introduce you to our speakers for today's session. Please welcome Raisa, Nekhaeva, and Juliette, Juanola.
Hello, everyone. My name is Raisa, and here I am with Juliette, and Juliette would be opening up this webinar with the first part of our conversation.
Sure, let me share my screen. Okay. Okay, perfect. So hello everyone, good morning, and thank you very much for attending today's presentation on the usage of AI and infrared thermography imaging in energy efficient retrofits. So before we start delving into the intricacies of AI and IR imaging, let me just quickly introduce ourselves and give you a bit of context on this presentation. So my name is Juliette. I currently work as a building science specialist, and I have a background in building science and energy engineering. My co-speaker today, Raisa, works as a project manager, and she has a background in architecture and civil engineering. Let me just try to make this go away. Okay, so as you all know, climate change is a pressing issue that is affecting every sector. And here are two figures that come from the World Economic Forum. So the first one shows that half of the global energy use in 2021 was consumed by the building industry, and the same sector was responsible for about 40% of the global GHG emissions. Here you see two illustrations that showcase the expected evolution of building climate zones across Canada by the end of the century. You can see that big shifts are expected and new climate zones are going to appear, especially at the south of the country. And this trend is going to be reflected on the heating and cooling requirements. So here are a few diagrams that show the expected evolution of heating and cooling degree days across the country still by the end of the century. And you can see that due to the rise of temperatures, the heating demand is expected to be lowered, while the cooling demand, of course, is expected to rise. So in order to address these climatic issues and disruptions, there are many strategies that can be put in place to make existing buildings and new constructions more efficient. We can talk about passive design strategies, and these strategies are supported by the regulation that is constantly evolving to make existing buildings and new buildings more efficient. For example, I think one of the main targets of the National Energy Code for Buildings in Canada is to make new constructions net zero by 2030. So this is a very ambitious goal, and it basically means that buildings will be meant to produce as much energy as they consume. This is a very ambitious goal, and in order to achieve this, of course, many strategies need to be put in place to make these buildings more efficient. This can also be supported by many programs and certifications. Some of them are cited here. And this is where new technologies really come to place and can help address these issues and make these targets realizable. So in this presentation, we're going to talk about drones, AI, and IR imaging a bit more. And in order to make you more familiar with these technologies, we prepared a few learning objectives that you can see here. So there are 4 main learning objectives that we're going to address today. The first one is the utilization of new technologies in building envelope energy audits. The second is the need for target retrofits, in order to achieve an optimal ROIs and minimize the building energy consumption. The third one is the application of building envelope energy audit and calibration of building energy model. And the fourth one and last one is the adaptation of sustainable building strategies and targeted retrofits. In order to achieve these objectives, we have divided our presentation into 6 parts that you can see here. So we're going to start by talking about the principles and how the energy analysis of building envelopes look like when using AI and infrared imaging. The second one will be the concept and talk a bit more about the science behind this technology. The third one is the interpretation, and we'll try to understand energy audit results. And the fourth part is really the application of energy audit results before we move on to concrete case studies to explain these concepts in a more concrete manner and to explain how they can be used in real projects before moving on to the conclusion. If you happen to have any questions at any time during this presentation, feel free to ask them in the Q&A box below. And we'll make sure to answer these questions by the end of the presentation. So let's start with part 1, the principles. So basically, there are many guidelines around energy audits. For the purpose of this presentation, we decided to focus on ASHRAE level energy audits. So basically, what is an energy audit? It is important for engineers to understand how much energy is being consumed by a building, and where the energy goes in order to identify capital improvement measures. So you can see here on this diagram that the energy consumption was broken down into 3 parts: the habits, the mechanicals, and the building envelope. In this presentation, we're going to focus on the building envelope more specifically and how AI and IR imaging can be used to address potential issues on the building envelope and make it more efficient. These technologies can also be useful when it comes to monitoring activities. So let's say that an energy audit was performed on a building. It can be very interesting for a property manager to monitor the efficiency of its building envelope after the retrofit was performed. And one of the interesting monitoring methods that can be used is infrared thermography, because it is non-disruptive, because it is very straightforward, and also because it is very visual, so easy to understand. And in order to process this data and analyze it, AI can be a very useful tool and very powerful tool to make it quicker and more accurate as well. We're going to talk about these technologies a bit more in the next slides. Yeah, these are really 2 examples to explain how they can be used in this industry. So when talking about the market, there are 3 major actors, which are North America, Europe, and Asia. So these have been pioneers in the industry. They have invested a lot of money, time, in research, especially in thermography, artificial intelligence, and thermography and drones, sorry. And of course, due to their climate, they're mostly tempered and cold, they are well established on the market, but this also means that there can be potential openings in other countries and opportunities in the future. So, like I said, one of the main advantages of infrared thermography is that it is non-invasive. And in order to perform an infrared thermography scan, the data needs to be collected first, then it needs to be analyzed, and then delivered in a variety of formats. In order to talk about this process a bit more and understand the science behind the technology, let's now jump into the second part, the concept, to understand how everything works. So before starting talking about the technology itself, it's important to understand how thermal cameras work. So this shows basically how infrared cameras work. So they receive infrared rays, and this is how they understand the environment. And this diagram really shows where infrared rays lie compared to visible light. So they really work with the temperature of objects. So to understand the concept of temperature, this is the measurement of the kinetic energy of molecules in an object or a system. So it's basically, it has to do with the speed of the movement of molecules within a body. So if you look at the left-hand side part of this slide, you can see that bodies with higher temperature have fastest moving molecules, whereas lower temperatures correspond to slowly moving molecules. If you look at the thermal image on the left-hand side, you can see that some hot liquid was placed into 2 glasses. So you basically see the contrast with the rest of the environment, and by the colors you can tell that the water or the liquid inside the glasses is hotter. And this is how thermography works, really. And eventually, through time, the liquid inside these glasses will match the temperature of their environment. And you can see on the same picture on the right-hand side that the glasses are almost the same temperature as their environment, and they can almost not be seen any longer. And same thing for the liquid. You cannot distinguish the liquids inside the glasses anymore. Well, this is what is called a thermal equilibrium. This is basically when the molecules inside the body match the rest of the environment temperature, and the temperature has become homogeneous. This concept applies to the building envelope because it separates the higher temperatures on the inside to the lower temperatures on the outside, usually in Canada. And this is really the same principle that applies, and this is how patterns can be detected and monitored through time. So these are a few applications for infrared thermography. There are many more, just some of them were listed here on this slide. And for the purpose of this presentation, we will focus on building diagnostics. But it is interesting to note that in the building industry, the infrared thermography can also be used for condition monitoring of machinery equipment. Okay, so these are the 3 main heat transfer types. So conduction is really the transfer of heat through a physical medium, an object. Convection is the transfer of heat through the air, and radiation is the transfer of heat through magnetic waves. For the purpose of infrared thermography, when it comes to building science, we tend to focus more on conduction, and this is really the main way we can spot building envelope patterns. So With that, there are 3 key areas that can be looked into on the building envelope. The first part will be the elements themselves, and this will help identify element losses. So this really has to do with the element's capacity to retain heat, and basically how well they are to insulate the building and how efficient they can be as components. Then the next will be thermal bridges. So this is related to the structure of the buildings, especially if it's a metal framed building. And the last one, infiltration heat losses, will be spotted at the connection between different building elements. And this represents a huge part of building envelope losses. So there are many tests that can be performed to make them more visible and increase the contrast when performing a thermography detection on a building envelope. For example, some companies will perform some blower door tests in order to increase the pressure inside buildings to kind of force the air to go out of the building envelope, and this will increase the contrast and make it more visible on thermal imaging. So there are really different methods that exist that can be really interesting to make this happen. So in order to collect the data, traditionally thermographers would go on site with handheld cameras. So you can see here on the top 2 examples of handheld cameras. So the main company, the biggest company that is selling cameras, handheld cameras on the market is Fleur. You only have 2 examples here, and this remains a very useful and interesting technology to use to perform these audits, especially when it is needed to collect data on very tight parts of the building envelope where drones cannot go. Or also if a thermography audit needs to be performed on the inside of the building. But it is interesting to know that, these cameras can also be installed on drones. So here the main actor on the market will be DJI. There are other companies that are coming in, such as Kaideo. But basically, if these cameras are installed on drones, it is possible to collect more data in very little time and to have more data points then, and also to access some parts of the buildings that usually operators would not have access to, or not as easily, such as the roof, or if you work on high rises or high rises mainly, you will have the ability to scan some upper parts of the walls and of the building. So it's very interesting. And in order to perform such scans, companies need to follow a few steps. So the main steps are mentioned on this slide. So there is the pre-operation phase, the data collection that can also be called the operation phase, which is why the previous part is pre-operation. Then the calibration phase to have the ability to then process the data, and then the delivering phase. So we're gonna go into more detail for each of these steps in the coming slides. Okay, so let's start with the pre-operation phase. So this phase is really meant to collect as much data as possible about the building prior to making the analysis, and also to plan for the flight. So the site inspection, first of all, is really meant to have a high-level overview of the building envelope before starting the analysis. So this really involves having engineers or operators going on site to collect some data about the building envelope condition. And this will give drone operators, the insight to know if there are specific parts of the building envelope they should insist on or collect more data around these spaces to gain more knowledge and know really what is happening The occupant survey is really there to collect data about what is happening inside the building and how it functions, what are its occupants' needs, to gain more understanding about the building and how it functions. So it really involves the energy consumption of the building envelope, the heating and cooling systems, if previous retrofits were performed, and if the occupants and property managers are happy with these retrofits, then it involves the occupants' comfort, how they feel inside the building. Do they feel cold in the winter? Did they notice any signs of moisture anywhere? This will give the insight to understand the building usage a bit more. So this is one part of the pre-operation phase. The other part is really about the flight planning. So the flight planning and the authorizations are really linked. So the flight planning involves having the ability to divide the building into different parts in order to store the data properly and really plan for the drone path in advance, because this is what is called a zoning file. The IoT devices placement can also be planned in advance. So this is really, these devices are meant to collect data about the environment. It can be the temperature outside, inside the building, on the surface of some elements. It really is many data as necessary for the purpose of the analysis, and this can also be based on the occupants and customers' needs. So I have to say that to have the ability to understand thermal images and to make proper readings, especially temperature readings, it is important to have IoT devices placed on the building and to monitor the outside temperature, humidity, and wind speed to calibrate the data. So these IoT devices can really be important. The weather conditions also need to be forecasted prior to flying the drone, because to be able to fly the drone, you don't want to have too much wind outside, because you can break the drone and crash it. You don't want to have snow falling. You don't want to have rain falling. So it's really important to verify the weather conditions as well. And of course, you need to coordinate the operation with the building operation management. The authorizations are also part of the flight planning, but they are very specific. A few are listed here, but they really depend on the location of the building, the country where it is located, the state, province, region, and even the city. For example, most big cities require that the streets are shut down before or at any time of the operation, because it is most of the time forbidden to fly industrial drones above people who would be walking for safety reasons, I'm guessing. So it is really important to have this knowledge about the authorizations that need to be collected. And yes. Then once this pre-operation phase is over, it is time to collect the data for the purpose of the analysis. So I talked about the IoT devices in the previous slide. So this is really how temperature and weather data can be collected all around the building, and the parameters that are collected really depend on the purpose of the analysis and the needs of the engineers and customers. And then in addition to thermal data, visual data can also be collected. So that can be interesting for two reasons. The first one is that it enables engineers to gain more knowledge about the building envelope whenever they are analyzing the thermal data. So for example, having like the visual data and thermal data side by side can really enable engineers to compare the same zone and really gain this understanding of what's happening out there. So this is like an additional type of information to perform the analysis. And the second reason is because it can lead to another type of deliverable that I'm going to talk about in a few slides. And then, of course, there is the thermal data collection. So this can be done by both drone data capture or handheld data capture. Honestly, having these two technologies together combined is really powerful because, like I said, they do not allow the capture of the same type of data. So this really gives like the highest quality data to use both technologies together. And the data capture of thermal data, the thermal data capture is really specific. If you want to have the highest quality data, this operation needs to be conducted at night to just get rid of the solar loads. So basically from 3 hours after sunset up until 1 hour before sunrise is really the best time to perform this type of operation. So once this data has been collected, it is time to process it. Like I said, in addition to the thermography data, there are a lot of data that can be collected that are very helpful to understand how the building works, how everything functions, and to gain this like very accurate type of knowledge on the building envelope and how it works. So of course, there's the building condition assessment that I mentioned previously and the occupant survey. Like I said, some on-site testings and measurements can also be conducted. I talked about the blower door test, so this really falls into this category. And thermography during this analysis part can be combined to AI to become a very powerful tool. AI will enable to increase the speed and accuracy of the analysis. We're going to talk about AI a bit more in the next section to explain how it works. But this is, this is really how it can be performed. Okay, once this data has been processed, it is time to deliver it to the customer. When talking about the deliverables, I think the traditional type of deliverable that almost always comes to mind is the reports. So these are sample reports from the Infrared Training Center. So this is really the basic type of information that needs to be delivered in an infrared inspection report. But these reports can be further enhanced and customized based on the customer's needs, whatever they want to compare the building to, if they want to address specific areas on the building envelope, and if there are references that they want to mention inside the reports. Then I told you about how interesting it would be to collect visual data with the drone. Well, this visual data capture can lead to creating 3D models through photogrammetry. So this is really using visual photos captured by drones all around the building to create a very accurate 3D model. That can happen to be a very useful tool, especially for planning purposes. It is possible to very accurately measure some parts of the building using this model. So for example, for this type of building specifically, you would have the ability to measure the size of a brick. So really, really interesting tool. And here a few companies are listed that can perform this type of service. And this is a really new type of technology and deliverable that is coming into the market. So this is an AI-powered detection video. So this video specifically is meant to highlight thermal bridges within a building envelope. So this is not the most accurate for now, but this can be a very useful tool to perform a high-level analysis of the building envelope. It can be especially interesting for monitoring purposes to gain some time and perform an analysis very quickly in a very cost-effective manner. So very interesting type of tool. Okay, now that I talked about AI a lot and how it works. Let's talk about, sorry, thermography. Now that I talked about thermography, let's delve into AI a bit more. So in order to talk about AI, I need to talk about thermography again. Okay, so there are really two types of thermography that exist when it comes to the building envelope analysis. So there is the qualitative thermography. This is what we are addressing in this presentation, really. So this is the detection and analysis of thermal patterns on a building envelope, whereas quantitative thermography is comparing temperature measurements of the healthy part, if I may say, of the building envelope with a specific pattern to determine the seriousness of the anomaly. So yeah, let's focus on qualitative here. Okay, so there are many factors that can influence building envelope patterns. A few of them are listed here, such as the climate, the building type, the materials, the design, the building usage, the installation, and many other external factors. And this slide is really to insist on the importance of data collection, collecting useful type of data to gain this wholly understanding of the building and the way it works. So really having a comprehensive type of data and amount of knowledge about the building itself can lead to the most accurate results. And if this data is missing during the analysis, it can lead to poorer results, if I may say. So this is really to insist on the data collection part. Okay, so here are a few pictures of building facades. So you can see that this was taken from a variety of building types, locations, and it is really hard to spot anything from the naked eye. Maybe on this on this picture here, you can tell that the facade is really old, but except for this, you cannot tell a lot. When you switch to thermal, however, it is much easier to spot that something's going on. So I'm thinking about this image particularly when you can definitely witness the cracks on the walls. So this is really interesting to property managers because this directly has an impact on the structural integrity of the building. That's the same thing for moisture. And this image is also very interesting. So what you see here is the argon gas leak through the window. The reason why thermal cameras can actually spot this is because there is condensation on the window surface. Yes, so what is interesting with IR imaging and thermal, building envelope patterns using thermal cameras is that they have very specific colors, shapes, location on the building envelope. And this makes it really interesting to combine it with object detection type of AI because it is recognizable, okay? So traditionally, thermographers would go on site, manually collect the data, then this data would manually be processed. And in order to manually process the data, it would need to be sorted out and only a few pictures would actually be processed. And then this data would manually be interpreted one by a person. Well, like I said, this characteristic that building envelope patterns can be pretty recognizable due to their colors, shapes, and locations makes it easy for an object detection type of AI model to be trained. So basically, in order to train this model, building science experts will annotate images and data then give it to a computer science expert, who will like use these images to train the model. And once the model is trained, it will be experimented and tested by the computer science expert. And if the test and the experimentations are not validating the model, then more data will be annotated and given to the model to be trained. Once the model is trained, it is deployed and it can be implemented in the analysis process. And then engineers will only have to review the images to make sure that everything is right. And this technology can really be a major breakthrough, as this can lead to the analysis of more data in very little time. So this is really, really interesting technology. So this is an example of an advanced data-driven object recognition type of model. So you can see that this model is really meant to detect thermal bridges on the building envelope. You can tell that it's recognizing most of them, even the mildest one. It is interesting to note that building operators can play with the level of confidence to only highlight the thermal bridges that they are interested in. The other interesting parameter is that this type of model has the ability to process about 50 images in half a second. So this is really hard to be beat by a human analyst. So once we use this type of technology, we can also think about the final product and how it can be enhanced. So this is an example of the end product that can be delivered to customers. So this is the 3D model, the type of 3D model that I showed you that can be created using photogrammetry. And you can tell that specific building envelope issues can be very accurately showcased throughout the model itself in a very high level of precision. This can be very interesting for property owners to understand how their building is doing, monitor the building envelope condition, and make informed decision with their budget and rank the issues. So yeah, this can be a very interesting type of final product and a possible enhancement for that. Okay, so I'm aware that I just gave you a lot of information. So this slide is really meant to summarize everything that I said up until now. So basically the principle is that drones and handheld cameras go on site and collect the data. Then this data is being processed by a computer-aided system using AI, and engineers will review the final product before delivering to customers. I will now pass it on to Raisa to finish this presentation. Thank you very much.
Thank you very much, Juliette, for your knowledge and sharing it. Now I would like to walk you through the second half of this webinar. So far we have discussed utilization of new technologies in building envelope energy audits. What are the main principles, concepts, and science behind the technology, as well as the understanding and interpretation of those energy audits. Now I would like to talk with you about different applications of those energy audits. So far, we can identify 8 main uses of energy audit results. We can use them for cost saving. An energy audit can help identify inefficiencies in energy use that can lead to significant savings on utility bills. By pointing out areas where energy is being wasted, owners can implement measures to reduce consumption and lower operational costs, which is really good for them. An energy audit can help improve overall energy efficiency. An energy audit can reveal opportunities to upgrade, replace, Inefficient systems such as HVAC, lighting, add additional insulation, which can lead to enhanced overall energy performance and comfort in the building. Therefore, building energy consumption will show a greater value for the money spent because we'll not be losing as much. Often, energy audits are used for compliance with the regulations. Many regions have energy codes and standards that require buildings to meet certain efficiency benchmarks. An energy audit can help ensure compliance with these regulations and avoid potential fines or legal issues, especially with current growing awareness of need to decarbonize our built environment. This use of energy audits becomes more and more applicable. And energy audits can help us increase the property value because energy efficient buildings are more often attractive to buyers and tenants. Improvements made as a result of an energy audit can enhance the market value of the property. Then an energy audit can result in improvements of environmental impact of the building. Reducing energy consumption helps decrease the building's carbon footprint, contributing to environment sustainability and helping owners meet corporate social responsibility goals. An energy audit can also address issues related to comfort, such as heating, cooling, and ventilations. It can help with improving the overall comfort for occupants by creating a more stable and pleasant indoor environment. I believe everyone present here is aware of a sick building syndrome and how it affects our cognitive abilities. Often conducting an energy audit can really help gain an intimate knowledge of your building and help you understand how building can be improved to provide a better comfort for its occupants. An energy audit can also assist us with predictive maintenance. An energy audit can help us identify potential problems early on and can help us prevent equipment failures. Therefore, that can reduce the need for emergency repairs, and we can achieve a more predictable maintenance costs. Often, energy audits can help property owners to obtain different incentive rebates. Energy audits are the part of the necessary documentation that needs to be provided in order to qualify for different assistance fundings when we're doing work on our buildings. And then also recurrent energy audits can help track a building's energy performance over time, providing valuable data from benchmarking against similar buildings or historical performance and guiding future improvements in our buildings. Energy audits can help us with meeting local regulations and applications for various certifications. So far, building codes establish the minimum acceptable standards for energy efficiency in new construction and major renovations. These codes are designed to ensure that buildings meet a baseline level of performance to reduce energy consumption and environmental impact. Codes are periodically updated to incorporate advancements in technology and knowledge. This means that the standards for energy efficiency become progressively stricter over time. However, green building certifications such as LEED, BREEAM, and other set more ambitious goals than building codes. They require a higher level of performance in areas such as energy efficiency, indoor environmental quality, and sustainability. Certification programs often incorporate the latest research and best practices in energy efficiency. They may encourage or require innovative technologies and strategies that are not yet reflected in building codes. Certification programs frequently update their criteria to reflect new advancements and promote continuous improvements in building performance. This means that achieving certifications often requires going beyond the current building code requirements. Energy audits can also help us maximize savings and unlock incentive rebates. In Canada, there are several rebates, incentives, and grants available for individuals and building professionals looking to reduce the costs of building retrofit projects. These programs often vary by province and territory, so it's essential to check for specific regional offerings. At the federal level, we have Canadian Greener Home Grant that offers up to $5,000 for home retrofits aimed at improving energy efficiency. Its funding is for improvements such as installations, windows, doors, heating systems, and more. To be qualified for this grant, homeowners are required to conduct pre- and post-retrofit energy audits. This program is for the residential homeowners. However, for large-scale construction, we also have Canadian Infrastructure Bank's Greener Financing that provides financing for large-scale green infrastructure projects, including building retrofits. A number of certification is necessary for securing this financial funding under CIB's building retrofit initiatives. It pretty much covers energy efficiency upgrades and renewable energy installations in large-scale buildings. At the provincial level, here in Ontario, we also have a couple of programs. First one is a home efficiency rebate that offers rebates for energy efficient upgrades such as installation and high-performing windows for homeowners. Another program that we have is the Save on Energy program. This program includes incentives for businesses and multi-unit residential buildings focusing on energy conservation. There are also other additional funding opportunities. Some municipalities offer local incentives for energy efficient retrofits. It is always a good idea to check with local government offices or about municipal energy programs. In Toronto, we have energy retrofit loans program where the city offers a fixed, long-term, low-interest financing to enable building owners to invest in a low-carbon, energy-efficient capital improvements. We also have an eco-roof incentive program with incentives for installing green roofs. Another program available is the Home Energy Loan Program, which incentivizes installing solar panel systems, air source heat pumps, multi-split indoor units, and any other deep retrofit solution that achieves an 80% energy reduction in home's energy guide rating. And finally, we have the organizations like the Canada's Green Building Council that may offer additional resources or funding opportunities for greener building projects. So there are a lot of different opportunities where buildings who have a tighter budget but would like to do some improvements and do some retrofits and work done can apply for funding programs and use energy audits to support their cases in their applications. Energy audits can help us maximize our property values, especially when it comes down to rental markets, selling the properties, as well as insuring it. In terms of its impact on the rental market, we can see higher rental potential since energy efficient properties typically have lower utility bills, which can justify higher rents. Tenants are often willing to pay premium for lower ongoing costs. In competitive rental markets, energy efficient features can also give an edge to a competitive edge to the property, allowing landlords to command higher rents. There is a growing segment of tenants who prioritize sustainability and energy efficiency. These tenants may be willing to pay more for properties that align with their values. Often, features such as an improved insulation, modern HVAC systems, and energy-efficient windows contribute to a more comfortable living environment and making the property more attractive to its occupants. Also, properties with certifications or verified energy-efficient upgrades may command higher rents. Certifications like LEED or Energy Star can serve as a strong selling point on the market. When it comes to sale of the property and energy, audits can also assist with similar benefits as the rent, increasing the overall value of the property. Energy efficient upgrades can lead to lower operational costs, which can enhance properties appeal to a buyer. Lower energy costs are an attractive feature that can increase a property's market value. According to the various studies, energy efficient homes often sell for more than their less efficient counterparts. The investment in upgrades can be recouped through a higher sale price of the property. Energy efficient homes are increasingly in demand, particularly among environmentally conscious buyers. Features such as solar panels, high efficiency heating and cooling systems, and energy efficient windows can make a property more desirable. As regulations around energy efficiency become stricter, properties that are already compliant or exceed standards can be more valuable as they will meet future regulatory expectations. Properties with recognized energy efficiency certifications can attract premium prices. Certifications validate the energy savings features and can positively influence the property's appraisal value. Energy efficient properties are less likely to face future costs associated with retrofitting to meet new energy regulations or standards. This forward-looking aspect can make them more attractive to buyers. When it comes to insuring the property, energy audits can help ensure work completion to the standards. They allow us to demonstrate the quality of the property's conditions and management, as well as assist with preventative measures for health and safety risk. There have been cases that we have encountered when tenants in the units have been complaining that it was always cold, and after the inspection have been conducted with the infrared thermography, it was revealed that prefabricated wall panels were missing insulation inside of them. Therefore, doing audits can really help ensure the construction is completed to standards and avoid potential legal issues. So the main target audience for application of the energy audits so far has been seen in the market. It's older building and landmarks, because these buildings usually have many different concerns, and doing an audit, comprehensive audit, can really help property owners rank the issues and see which ones need to be addressed first, which are critical, and which ones can wait until the better times. Another big client group for these type of audits is large facilities like university campuses. When they have multiple buildings on site, they have a large site that needs an audit to cover it. The audits using the new technologies that have been presented by Juliette, such as application of drones and infrared thermography, often offer you a more time-effective data collection and analysis, where the results are delivered to the client, and then the client can rank the issues across their buildings and really see which buildings are performing well, which buildings are not performing well, and then they can distribute the budget accordingly. And another big client group for this type of audits are the businesses, particularly property managers, hotels, or companies that own many different buildings, or they oversee many different buildings in different locations. Having these audits really helps them standardize their knowledge about their buildings, helps rank the behavior of their buildings, and then often these type of companies have energy audits on the reoccurring basis, where once a year or once 2 years they conduct those audits to really be on track with the behavior of their buildings and how they're doing. So this type of audits can really help collect your knowledge about your building in a time-effective manner and process this data at the very low costs. Now, I would like to walk you through a couple of the case studies where these type of large facilities have been scanned, there have been processed the data, and then the results have been delivered to the client. So we would be mainly looking today at, first of all, large healthcare facility. Then there would be a large institutional project, and then there would also be a large commercial project that's borderline with the infrastructure. So the first case that I would like to introduce to you today is a large Canadian healthcare facility. This facility is over a century old and located in a dense urban area. So because this building was initially built in 1890s, I believe, and over time, more additions have been added to the building, more different parts have been either other wings or constant upgrades of the mechanical system, constant retrofits. So this facility, I believe, overall is over 100,000 square feet big. And they have conducted energy audit with the new technology because they were primary concerns that this is a healthcare facility. They're servicing hundreds of people. It's working 24/7. Therefore, they could not stop their processes to conduct any other sort of audits. They have sent a drone pilots to collect the data, and it took them under 1 day to collect over 5,000 data points. That's including both infrared thermography and visual imagery. All of these data points have been processed with the AI. I have to let you know that this AI was hosted on a very strong server. So it took it under a minute just to feed all those data points into machine learning, and then machine learning spitting out all of those images, identifying all of the different issues on the building envelope. And I believe in total over 250 images, over 250 issues have been identified for this particular property. And it really helped the property managers to quickly rank their retrofit plans and see what issues need to be addressed first and which issues need to be addressed second. When this facility, property managers have went to a traditional energy audit, they were shopping around, and what they have found is that traditional energy audit would take them about 5 months long and would be very expensive to conduct, which of course has its own place to be if they're looking for very meticulous details. However, application of the new technologies as well as application of artificial intelligence really helped them to get a big picture about the health of their building and see which areas need to be focused on. The next case study that I would like to show you is a large institutional project. So this is a campus. It's a college campus here in Ontario. And this particular site had 5 buildings. The clients on this project, I believe they were in a big rush. They needed for the scans to be conducted very quickly because it was related to their funding opportunities as well as their budgeting. They had to figure out the fundings and budgeting and work that needs to be done on this facility. So they also hired a company that went in and scanned all of those buildings. So 5 buildings have been scanned in 22 hours, which is one of the record times that have been seen out there. And in these 22 hours, they have collected over 25,000 data points. That means visual as well as thermal imagery. And then when this imagery have been processed with the artificial intelligence in a very short time, that engineers were seeing that it identified over 1,300 different issues on this project in this particular campus, allowing property managers to really sit down and see which parts of the campus needed capital investments and improvements, and how improving those particular parts of the campus will improve the overall behavior of the campus and overall behavior of the energy efficiency of the campus, reducing their energy consumption, and really helping them to distribute their fundings. Some of the challenges on this projects were because it was a very time constraint. The clients were in a rush to conduct those scans. Therefore, the pilots had to go on site during the winter. And as Juliette mentioned earlier, the flight conditions are very important for safety and accuracy of the data that is collected. Therefore, I believe there was a lot of coordination done to make sure that snow does not get in the way of the drones and all the data can be collected safely. The last case study that I would like to introduce to you is the large international airport located on the east coast of Canada. And this is a very unique project because it's an airport, right? And airports cannot really shut down and close off for complete drone flights. And what happened here that there was a lot of work done beforehand to obtain all necessary flight permissions, make sure that all the work is done confidentially. There needed to be a lot of work done with Navigation Canada, making sure that all of the pilots would be able to fly there and there would be no cross information. So they were able to close off this airport between 11 o'clock at night until 4 o'clock in the morning, which is only 5 hours of total flight time for the drones. And it required a lot of team members to be on site. So it was multiple flights occurring at the same time. Overall, this data collection has taken only 12 hours. If we recall the first case study that I have shown you, it has taken a day. So this data was collected in half the time, and about the same amount of data has been collected for this project. So over 5,000 data points. And then once these data points have been processed, over 250 issues have been identified in this airport facility, and some majority of them being located on the roof, which really help property managers to focus their attention on the roof of the building, making sure that it's all the needs of the building would be met in the upcoming years of the maintenance. So far, we have went through all the different case studies and application use cases. And now I just would like to do a conclusions part to wrap up this presentation for you. So I just walked you through the various ways the energy audits can be beneficial, especially in the case of the building retrofits, when we want to improve our energy efficiency in our facilities. Just to wrap up everything, I want to mention that we see a clear need on the market for energy audits. We need building retrofits to make our buildings better performant. We want to make sure that we have a proper maintenance plans in place, as well as with the ambitious guidelines, building property owners and architects will target deep retrofits that will allow them to earn different awards and certificates. And with the traditional use of the energy, with the traditional procedures of the energy retrofit, with the current demand, unfortunately, it cannot be met. Therefore, new technologies are coming up on the market, such as application of the drones, application of the infrared thermography, as well as the application of the artificial intelligence to do a batch processing of the data. So when we're doing our energy audits with using the infrared thermography, we really enhance the precision of the information, because detailed temperature readings across surfaces can help pinpoint exact location of heat losses and heat gains in the building envelope, and get a quick and comprehensive assessment of the large areas, reducing the time needed for manual inspection. It helps us to visualize our data. It can help reveal hidden issues like air leakages, inconsistent insulation, or decay of insulation, moisture accumulation, and penetration that may not be visible to a naked eye, as well as it offers a clear visual evidence of what areas needs to be improved, and building a strong cases for the clients. And then it also helps us with the cost effectiveness. It helps prioritize repairs and avoid costly future issues, as well as infrared thermography is a non-destructive inspection method. So it does not require us going and poking the holes inside of the building. Once we throw artificial intelligence and machine learning into this combo, it really can help us to enhance the accuracy, giving us a higher precision analysis, as well as it reduces the error rate. Automated analysis opens the possibility to process the large amount of infrared data quickly, and then also provides a real-time insights, as well as reduces the need for manual interpretation. If we're able to obtain the historical data from our buildings and combine it together with the infrared thermography, we can build out the models that can help predict potential issues before they even become serious problems. So it's proactive and predictive maintenance. Artificial intelligence really enhances the ability to detect complex issues such as hidden leaks and insulation issues by recognizing the patterns and trends in IR imaging. Therefore, it can see the issues that will become the future issues, however, they're not present now. And also artificial intelligence really can ensure the consistent analysis and reduce the human error, providing a reliable results across different inspections and scenarios. And with that, I would like to wrap up our presentation. Thank you very much, everyone who has been attending, and now we would be addressing your questions.
Excellent. Thank you so much, Raisa and Juliette, for the presentation. And this is just a reminder for our members, if you have any questions now for our speakers, please post them into the Q&A window. Raisa and Juliette are going to address all these questions now. Thank you. And Raisa and Juliette, I think there are already a few questions in the Q&A window.
Yep. One of the questions, if you will be getting a copy of the presentation, I believe that's the case. You would be getting a copy of it after the webinar.
Yes, that's correct, Raisa. As always, our members are going to get to receive a copy of the presentation in an email after the webinar shortly.
Sounds good.
Okay, then I think there is a question. With the new advanced tech, do you still need a certificate to operate an IR cameras or drones? I think IR cameras are something and drones are something else. For sure, if you want to perform an operation using drones, you need to have certifications. Raisa, do you know what certifications exactly?
So when it comes to the infrared thermography and the drones, as Juliette mentioned, there are two different types of certifications that are required. For the infrared thermographers, you can buy an IR camera yourself for your personal use and do your own analysis scans of the buildings. However, if you want to be issuing the reports, there are also certificate licenses available from the Infrared Institute. So you can become a thermographer level 1, 2, or 3. So those would be the part for the IR cameras. As for the drones, there are small private drones that are available on the market, and those drones usually are not able to collect their infrared data, but then there are also different more industrial grade drones that I believe Juliette has been showing in her presentation. And these drones, to fly them, you need a pilot license. On Government of Canada, there are two types of pilot licensing, pilot license 1 and 2, and it's a very straightforward procedure. You just go online, you take some course, and then I believe you need to do a flight with already a licensed pilot instructor, but it's relatively easy to obtain those licenses. For the equipment, equipment can be more difficult to come by. I believe that it can be purchased, but also there should be companies where it's available for rent, because drones that fly infrared cameras, they're a bit bigger and they can lift more weight than little drones that we can see that use for recreational use. I hope that answers your question.
I think, yeah, there is another question about window frames. So if they're causing thermal bridges, what is an alternative solution other than replacement?
So right now out there in the market, different companies are looking to address this issue. I believe there is a company from US, they're called Inefficiencies, if I'm not wrong. And this company created a window insert. So pretty much you have a window itself, and then you put on top of it, you put an insert from the inside that's supposed to prevent your thermal breaks. So it's insulating your window frame from the inside, and also it adds another pane of glazing to your window. So that's one of the solutions that I have seen on the market.
Felix, I think the next questions are about receiving the link to this session in email, and yeah, can you answer this, please?
Yes, of course. Members will get a copy of the presentation. If they would like to watch the webinar again, sometimes we post webinars onto our YouTube channel. So I suggest, Masood, you keep an eye onto the OAA's YouTube channel as well.
Okay, another question about the drones. Do we have to acquire a permit to use the drone? I think it depends on the size of the drone, but technically, like Raisa said, drones with thermal cameras are kind of bigger than the drones that are used for recreational use. So industrial, I think you need a permit for a drone that weighs more than 250 grams, something like this. So I think, yes, it does require a specific permit. I am not sure about the permit though. Raisa, do you?
Yes, you're correct. So the permit that we were talking about to fly the drones, you will require a permit from Navigation Canada. And Navigation Canada, so usually it's an app or an online, you go before your flight and you log in, and once you have your pilot licenses, you would go in and you just would send a request to flying your larger drone at certain times in a certain location, and they either approve it and give you a permit, or if, for example, it's a high sensitivity areas, you might not be able to get the permit. We have seen some areas, particularly in downtown Toronto, where it's either starts become very sensitive because it's close to Billy Bishop Airport, or because there are, for example, some government facilities that are super high confidentiality and they don't allow you to fly drones next to their buildings. Are there any other questions?
If there are any other questions to our members, please post them into the Q&A window now. If not, Julia and Juliette and Raisa, do you have any closing remarks? Oh, sorry, there's just another question came into the window.
So the question is asking, how do we get a pilot license and where we apply for it? To apply for a pilot license, it's done through the Government of Canada. So you just go online and you look for the pilot license level 1 or level 2. There are two different levels that give you different clearances on where to apply, but it is done through Government of Canada.
Perfect. So as there are no other questions, Raisa and Juliette, thank you very much for a great webinar and discussion today. Also, thank you everyone who attended. And as we conclude this webinar, I would like to draw your attention to just some announcements. The next webinar takes place next week on September the 26th with the title Navigating Ontario's New 2024 Building Code. The OAA, as mentioned, will report your participation in this webinar to your transcript. Therefore, there's no need for individual reporting on your part. And also, as mentioned, the attendees will soon receive the presentation file via email along with a link to provide your feedback. Once again, thank you very much for your attendance and have a productive and pleasant remainder of your day. And also, Raisa and Juliette, thank you very much again, and it was great having you today. Bye-bye.
Thank you very much. It was our pleasure.
Thank you very much. Have a good one. Take care.
Bye-bye, everyone.
Bye-bye.